Welcome all. The topic of today's mini chapter will be I/O redirection, so input-output redirection. What is it? We have used it thus far, but I haven't really explained it extensively. Redirection is taking the output from some sort of a file, script, or a command and redirecting it as input to another file, script, or again command. Files that are always open by default are stdin. This is the keyboard input. stdout. This is the output on the screen, and stderr. This is the error message output on the screen. Each of these files are assigned some sort of a file descriptor. So 0 for stdin, 1 for stdout, and 2 for stderr. stdin is standard input, stdout is standard output, and stderr is the standard error. File descriptors for additional files, they range from 3 to 9, and sometimes it can be a good idea to assign one of these descriptors to stdin, out, and err in order to serve as some sort of a temporary duplicate link, but we're going to go ahead and skip that for now. So let's go ahead and take a look at some examples. Let's go to our script and type in file equals wood.txt, because that's the file that I have, and I'm too lazy to rename it in any fashion or way. Echo, this line is sent to file 1 file. Is it? Yeah. Anyway, so what do we have here? What is this? 1 greater than. Well, we have a file here to which we direct something, and we will redirect the standard output to this file. Basically, the standard output of echo is whatever we write here. This is sent to this file, and then all this entire line that is printed out onto the screen usually will no longer be printed out onto the screen, but rather instead it will be pushed into this file. So this is just the simple redirection of standard output. Let's go ahead and run this. Oh, by the way, just to prove that I don't have anything in wood of significance. You see, it's just tralala test, whatever. But now when I run the script, and when I cat out wood, it says this line is sent to wood.txt. This line is sent, and then we have a file name here, which is wood.txt. Just readjusting myself in my seat. Anyway, to redirect a standard error to a file name, you would do the following thing. But let's go ahead and use this in a bash, just in a terminal. If I just type in something on the command line and press enter, it's going to say bash something, command not found, and an error message. So if I would like to redirect this error message, I can type in 2 greater than, and let's redirect it to a file, wood.txt. Cat wood.txt. And excellent, it says this line is sent to wood.txt, but down below it says bash something command not found. Why is this added? Well, if you remember in the previous tutorials, I mentioned that when adding 2 greater than signs, you are appending the file. You're not actually substituting what is already in it. But the standard error was redirected. Now, there are some strange cases where you would redirect standard error to standard output. How would you do that? Well, it would do something like this. Let's clean the screen first. Clear the screen. Greater than wood.txt space 2 greater than ampersand sign 1. But wood.txt already exists. Let's name it wood1.txt. So this will create this particular file, and then it will redirect the standard error to standard output. Let's press enter and see what happens. Nothing. There is no error. If I type in ls wood1.txt, it will indeed list it there. It exists. It has been created. If I just type in this, you will see that there is nothing in it. It is completely empty. But we didn't have any problems there at all. That was just, it created it and the redirection was done, but there wasn't just anything to redirect. However, down below, if we type in something, as in a non-existent command, and if we redirect, and if we do a redirection here, wood1.txt, and then we're gonna do 2 greater than and sign 1. This will append both standard output and standard error to basically wood1.txt. Let's see what happens here. Cat wood1.txt. There you go. You see, standard error was redirected. So both standard output and standard error were redirected basically to this particular file, and as you can see, this is what we have here. There was pretty much no standard output, but you had standard error, which you can read from here. Bash something command not found. I know it's a bit of a strange and weird concept, but I just wanted to run a few of these by you, and some of them more important than the others, but oh well, it's good for you to know them in general. Okay, so let's go ahead and minimize this and go back into our bash script. Let's delete this. So, to assign a file descriptor, we will need to do the following. Let's type in echo 1, 2, 3, 4, 5, and then greater than sign, and I don't know, I shall type in fd, meaning file descriptor .txt. It should create the file if it does not exist. And then down below, we will type in exec. And now we shall have to type in something weird like this: 3 lesser than greater than fd.txt. So this will basically open up the file, the specified file, and assign a file descriptor 3 to it. Now let's go ahead and enter and go into read-n to lesser than and $3. This will read only 2 characters, if you remember from the previous tutorials, from a particular file. So let's go ahead and see how that works out. Next up, we will type in echo space -n space dot space greater than and $3. Down below, exec 3 greater than and $, and now we have a minus. Excellent. So down below, let's just see what became of all of this. Cat fd.txt. So echo -n dot greater than and $3. This just means that it will write a decimal point there. And down below exec, it means that it will close the file descriptor 3, and then it will actually list the lines of the file descriptor file, and that's pretty much it. So it should print out something like this. Okay, so we have problems. Let's go ahead and see what they are. Okay, read n option requires an argument, and I am missing something here. Let me just see what it is. -2 and right. I need a space. Sorry for the confusion. No big deal. We all make errors, as long as you can find them and correct them. That's nice. So just a small space here was a problem. Let's go ahead and run it. Excellent. So it says 1245. I know, this is a bit weird, but we have specified such parameters here. So let's just go over them one more time. I know that this can sometimes be a little bit confusing. So first, we write 12345 into a file called fd.txt. So we echo out and we redirect the standard output into fd.txt. What we do next, it doesn't matter. What we do next here is open the fd.txt and assign a file descriptor. We assign a file descriptor 3 to it. Next, we read only 2 characters from the file with this command here. And then we write a decimal point there. Afterwards, we close the fd3, and then we will list the lines of fd.txt, and that's pretty much it, with meaning 12.45, meaning 12, and then instead of 3, we have 45, as we have formatted the output in such a way. So I went one line over one line. I've demonstrated to you the output. If I know that this can be a bit confusing, believe me, I know, I feel it. Sometimes I get confused with these things as well. Please feel free to visit the discussion section. That is why it is there, to help you as much as we can in order to understand this. Anyway, I bid you farewell, and I shall see you in the follow-up tutorial.